Hello, welcome everyone, and thank you for joining us for the Recharge Your Battery Expertise and Boost Your Battery Testing Knowledge webinar with Ken Clark, Managing Director at Rotronics Battery Management Solutions. Hi, Ken.
Hi, Georgia. How you doing?
Good, very well, thank you. How are you doing?
Very good, very good.
Perfect.
Looking forward to the football this evening, eh?
Yes, I'm sure. I am, and I'm sure everyone else who's joined the webinar is also. Okay, so just before we get started, I just wanted to go through some housekeeping with you all. So if you have any questions that you would like to submit throughout Ken's presentation, then you can do by submitting them in the Q&A box below. Questions are really important for feedback and gaining more knowledge. We will have 15 minutes allocated at the end to go through these questions. Any questions that we don't manage to answer during the session will be answered offline after the webinar. This webinar is also being recorded, and the recording will be made available to you by the end of this week. I will email everyone who has attended and registered for this webinar, making them aware of this, and also with a link to our feedback survey. Perfect. Okay, so without further ado, I'd like to hand over to Ken for his presentation on battery management solutions.
Superb. Thank you, Georgia. And thank you all for joining us this afternoon. Appreciate you giving up some of your valuable time to listen to what we have to say and what we're all about. Right, so without further ado then, just to give you a bit of an idea for those of you that don't know who Rotronics are, Rotronics is a division of Rozone Limited and part of the Rubrio group of companies based in the West Midlands. We work alongside automotive fleets, commercial vehicle workshops, and any application, I guess, where 12 or 24 battery sets are involved, incorporating battery maintenance programs into everyday vehicle maintenance regimes and routines using Midtronics and CTEC diagnostic testing and charging technologies. Our key objective really is to reduce the impact of roadside defects and on start, which we can demonstrate as to improving that by as much as 50%. And obviously looking to increase battery life cycle performance in doing so. The development and introduction of a Robis system that we call Rotronics Online Battery Information System some 2 years ago now enables us to give customers and workshop management a very sort of helicopter view and under the microscope image of what's going on within their workshop compliance and battery testing procedures and processes. And we'll run through that a little bit later in the presentation. So where I wanted to start off really is just giving you a bit of a background about the evolution of battery testing. So we're all probably very much familiar with the original load type testers and voltmeters that have been used in the past to identify battery defects. Some of these still exist in workshops today, but certainly a few and far between these days. Back in around about the 80s, we saw the introduction of conductance-based testing. Using a handheld device where a small AC measurement is placed across the battery to measure the internal resistance. From that point, we've moved on a little bit to now what we see is EFB batteries. In the past couple of years, we've seen a massive increase in enhanced flooded batteries coming into the marketplace, primarily to support things like stop-start vehicle applications. And therefore, we have to treat those batteries slightly different to a regular flooded battery in the way we test them. If we then move on from that, we now incorporate things like connectivity. So the inclusion of our Robis online portal, so we not only get the test result at the coalface, but we can analyze that data and upload it to our server. So you can analyze and gauge how well or bad your performance is against other workshop environments, and also see the opportunity that comes from that. If we take a step further on again, we've now got the need for controlled load testing, so reserve capacity testing, and also Wi-Fi connectivity. And again, this is all brought about really with the infrastructure supporting stop-start vehicle applications, where we're not just now required to test the starting capability of the vehicle, but more importantly, we want to know what reserve capacity the battery has to support all the consumer loads and the stop-start systems of the modern day vehicle. Moving that to one stage further, we now have the ability not only to measure the cranking amps, the reserve capacity, but also the charge acceptance of the battery as well. So we now have 3 key components that we're looking to test and diagnose the battery. And if we move forward right into today's sort of environment for electrification, we've now got devices such as module balance units and recovery chargers for supporting electric vehicle applications. Linking that all in, Rotronics can clearly give you a good overview of something that you may require for today's market and for future requirements as well. So we're going to start off really with just a quick couple of audience polls. So I'll ask Georgia to kindly sort of open up a couple of questions for you guys to answer for us, and we'll share the results with you. So the first question we've got there is, do your technicians test the battery of every vehicle that enters your workshop as a routine application? So if you can just submit a yes or no answer to that one, it'd be much appreciated. I'll just give you a couple of seconds to fill them out. Okay, so I think we're there, Georgia. We can close that poll off and see the results, I guess. Okay, so we have 38% say yes, and an interesting 63% say no. So we'll pick up that topic a little bit later, but it's an interesting fact there. We've got the other question there, George. Is there another one coming up? Great. So do all your technicians charge the battery of every vehicle that enters your workshop according to the battery test results? So if you can just simply answer a yes or no there again, please. And great, if we close the poll on there then, Georgia. Okay, and we have a similar picture there again. So 31% of you say yes and 69% say no. It's a very interesting, I don't know if that was what everyone thought, I guess, on the session here, but very interesting comments for sure. So we'll now close that down and move on. Okay, now we know a bit about the sort of test. So what is actually conductance technology? So conductance is a measure of the battery's ability to conduct electrical current using a small AC signal. So that's what we call measuring the cranking current of the battery. We then have reserve capacity, which is a measurement of the battery's ability to sustain a minimum system voltage in the event of a charging system failure or engine off loads for stop-start systems, if you like. And we call that the endurance of the battery. Then we have the third component, which is charge acceptance, which is pretty much what it says, the battery's ability to accept charge current, whether it's from an alternator or from an external charger. So conductance profiling is a mix of all those 3 characteristics to measure the battery's ability to perform, not only to start the vehicle, but to deliver ongoing power for starting and consumer loads going forward. So you can see, whilst the technology is moving on, we can see why we have to make that drive and change in the way we operate going forward. So why do we need to change the way we test batteries? So if we look at just going back a little bit in time to look at the battery demands that were on vehicles back maybe in the 80s or before then, we can see that battery was mainly used to start the engine. So a short high power demand requirement, a bit like a sprinter, I guess. Few consumers were left on when the engine was operating. We didn't have stop-start systems in place back then, and the battery was just merely required to provide a loop in the electrical circuit and provide power to start the vehicle. Emphasis was on testing the cold cranking amps of the battery to determine whether the actual vehicle could be started. So conductance measurement being the sole purpose of the test process. And there's just an inset picture there showing you a typical early days application where you've got a single fuse feed to the radio in the starter, and that was pretty much all the battery was required to do. Now if we change that now into what we are looking at in today's environment, we can see we've got very high vehicle consumer demand requiring much more power for longer. Starting the vehicle is merely not the requirement anymore. So lots of engine on and off loads such as stop start, consumer loads. You've got to look at the modern day vehicle. You've got lots of the consumers that are now standard on many vehicles, such as aircon, heated seats, electric windows, and the list goes on. So increased vehicle technology supporting those passenger comforts we all come to like and get accustomed to. Stop-start systems, as we've said. So conductance and reserve capacity become much more of an important characteristic for us to determine whether the vehicle battery can sustain the power that we need for much longer. And again, you can see there in the inset image there, the typical feed these days, you've got more than 3 feeds and plus 100 amp fuses under the bonnet. So we can see there's a hell of a lot more going on under the hood to support the battery and the vehicle requirements. So again, if we look at changing battery technology, EFBs, which you may or may not be familiar with, it's a fairly new entry to the marketplace, I guess, really. We can see that AGM is still fairly prolific in the marketplace, but the standard sort of starter lights and ignition battery, or what we call is the flooded battery, is dwindling down as years go by. So EFBs are really growing in their market share and replacing the traditional lead acid battery. So we can see they're up into 2020, roughly 50% of those batteries used in vehicle applications are what we know as an EFB battery. And these quite often have to be tested using a specific algorithm. They're not the standard traditional battery type that we'd see in any other vehicle. So we've built within the Rotronix testing profiles a number of battery lookup tables to support enhanced flooded batteries. So on that basis, why the need for testing? If we consider a battery to be a power source with a tap, every time the vehicle needs energy, the tap opens, allowing power to be used. So the vehicle charging system then recovers the battery where it can during the drive cycle. So that's all taken care of. Do we need to then look at testing the battery or charging it? And there's various reasons as to why it is important that we do that at regular intervals, such as things like temperature will affect performance. I mean, we're lucky we do get the odd summertime period. Certainly last year we had a very nice summer. This year it's not looking so good. But temperature, whether it's cold or extreme temperatures, can affect the battery performance and life cycle in itself. Driving habits, typically, you only got to put into perspective, the amount of driving that people have or haven't done during the pandemic and shutdown. That has an impact for sure. Short stop-start journeys, with stop-start vehicles now, whilst the batteries are enhanced flooded batteries or AGM, the battery will still, take its toll on the systems if we're using the vehicle just for short journeys. Battery age clearly affects battery performance longer term. As soon as a battery is made, it starts to deteriorate, and the longer we leave those batteries in the discharge state, will further decrease the ability of that battery to last for as long as it should do. Battery voltage and sulfation is a key element of that as well. Correct battery application, again, making sure we fit the right batteries for the application. Never used to be a major issue, I guess, but when you look at now with enhanced flooded batteries, AGM, stop-start, it's very important that we choose the right battery and size for the application that we need it to perform. Otherwise, we'll reduce that lifespan considerably. Consumer loads with ignition off. Clearly, if you've got a customer driving around short journeys, leaving the aircon on all time or engine off loads and having the radio, etc. on, batteries won't last very long. Lockdown has a massive impact, and I guess a lot of you that are in the business today will probably have seen that as we start to ease out of lockdown, that you're seeing a lot of customers with battery defects. I mean, talking to some of the battery manufacturers out there, when we came out of lockdown in the first stage, it was almost like having 3 winters in one. There was an abundance requirement for battery replacements, and certainly the roadside organizations were attending, significant heightened numbers of battery failures out there. So all of these issues have an impact on the battery's ability to perform and stay healthy. Batteries do need to be maintained sufficiently. So if we then consider that and move on to 24-volt battery sets, we get double the trouble in effect. We now only have not just one battery to contend with, but both of them. And a key feature of batteries falling out of balance is a key sign that the batteries are starting to become defective and need attention. So if we look at a 24-volt battery set, as we see in the image there, we can clearly see that, whilst we've got, voltage of 25.4 in the pack voltage, that's great and always good, and the battery is in a healthy, balanced state. But as the battery gets cycled, energy gets taken and charged back into the battery set, this becomes uneven across the two batteries and can cause a bit of a disparity. So as we see that over time, we can see that overall the pack voltage is often going to be above 25 volts across the pack. If you test the batteries individually, you'll quite often find there will be an imbalance, not only on voltage, but on internal capacity of the battery as well. So we can see there in this example, we've got battery 1 at 12.2 and battery 2 at 12.7. So the overall pack voltage is relatively well. But in this condition, we will start to see an increased likelihood of sulfation in battery 1 and the risk of overcharging in battery 2, which is typically why often commercial vehicle workshops will replace both batteries, even though only one battery is defective. But there are systems in place and testers that you can use to ensure that the batteries are either a good pair, in balance, or out of balance, and remedy that by charging the batteries. And again, leaving batteries in this condition will only lead to premature failure. So the way to remedy this is to proactively test both batteries individually as often as possible, but more importantly, charging the batteries individually to maximize their charge capacity. If we just simply hook up a 24-volt charger, the battery with the least amount of resistance will take the lion's share of the current, and the battery with the hardest sort of charge acceptance won't get enough. So one gets starved and one gets too much, which again increases that likelihood of outbalance and the risk of further degradation of the batteries. Okay, so right, we have another poll question for you just to keep you bright and bushy-eyed today. So Georgia, if you kindly open up the other question for us, please. Okay, so what is your primary reason or motivation for testing a vehicle's battery? You've got a couple of options there, whether it be preventative maintenance to generate a battery replacement cell, part of general workshop practices and processes to provide good customer service, or none of the above. So again, if you can just quickly answer those for us and just submit your answers. Great. Okay, Georgia, if we'd like to close that poll and see what results we have. So again, quite an imbalanced picture there. So we've got 58% of you look at doing the testing as a preventive maintenance, which is fantastic. None of you do this testing to look at for replacement cells. So that's a good answer. 26% of you offer the service for part of general workshop practices and processes. 5% with good customer services, and 11% none of the above. So feel free to pick up a question or two with us at the end of the session to see what else we can look at there. So thanks for that, Georgia, much appreciated. Okay, if we move on. So where does this leave the actual introduction of electric vehicles for 12-volt batteries going forward? There is a perception out there that electrification will cease and see the demise of the good old 12-volt battery, and that's certainly not going to be the case. Electric vehicles still require a 12-volt battery, which remains very much an integral part of the vehicle system. So why is that the case? So electric vehicle batteries need to be charged and controlled, and that requires a computer to manage which is powered by the 12-volt battery in itself. So if you look at the batteries, the vehicles of today, the heart of the system is the 12-volt battery, and even in electric vehicles going forward, that 12-volt battery is so important, and probably more so with modern day electric vehicles and PHEVs to support the infrastructure. So in addition to this, it provides power to other 12-volt applications, so such as lighting, in-car entertainment, heating and cooling systems. And if this battery is allowed to go flat, the vehicle will not start, irrespective of what charge we have in the electric vehicle batteries. And incidentally, RAC and AA sort of breakdown organizations are seeing quite a heightened increase in non-starts related to EVs, purely as a result of this battery going flat. So the battery is often charged via DC-DC charging system from the EV pack. So if we've got an EV pack that's low, clearly there's not enough power to charge this battery back up, even though we've got consumers running 24/7. So again, the issue doesn't go away. We should still look at proactively looking at these batteries and maintaining them wherever we possibly can. So if the 12-volt battery does go flat and the vehicle won't start, there is a means to rectify that through charging. So most of these batteries will be AGM batteries, some are lithium, but a typical AGM battery can be charged using a standard smart charger or a lithium charger if it's a lithium battery. But certainly it's something to watch out for. So if we look at the charging infrastructure today and tomorrow, so whilst we're on the topic of electric vehicles, we can see here that in London primarily is where we see the most heightened number of charging stations supporting electric and PHEVs at the moment. But if we look at some of the facts here, then really, if we're now looking at a charging infrastructure supporting the UK, we can see that 1 in 3 households rely on street parking. So great if we have a charging infrastructure, but where does that leave individuals that haven't got a car parking space outside the house, or want to share it with the neighbours who doesn't want to give up that space, presumably? There are 40,000 public charging points in the UK as of this moment in time, and 2.7 million charge points are required by 2030 if the government are going to hit their target for the green energy environmental policies. So there's a hell of a challenge ahead of us now to not only get consumers on board with buying into PHEVs and electric vehicles, but actually the concern probably, I guess, and it's one I share, is where do I charge my vehicle up? 700 new public charge points a day are required to meet this 2030 plan, of which 1.9 million of these will be classified as pure public charging points itself. So that equates to really, a current build of around about 42 units per day. You can imagine there then, that there is certainly a massive target to be achieved if we're going to hit that target. So yeah, I'm sure the government will put plans into place to increase that, but it just shows what we're up against in the industry today on how we meet those standards. So again, if we look at the growing market share in electric vehicles and PHEVs, it's certainly on the increase. If we go back to as far as 2017, we can see that there were the market share was less than 1.9%. It grew to 2.5% in 2018, 2019 up to 3.2%. And okay, it's gone up now to 10.7% in 2020. So there is certainly a heightened increase in demand from consumers and the way the government policies are pushing us down that route of moving across to PHEVs and electric vehicles. So putting that into perspective, I guess, of the 35 million cars on the UK roads at the end of 2020, roughly 1.2% were plug-in hybrids, and battery electric vehicles made up less than 0.6% of them. So there's a long way to go yet. Be interesting to know how many of you guys are driving around in PHEVs or electric vehicles, or your next car will be whether it's be a PHEV, an EV, or whether you're going to stick to the diesel or the petrol engine, I guess. But it's certainly an interesting topic, and one that will be very much of interest over the next coming years as that continues to develop. So I guess really what we want to talk about now is the hidden battery killer, which we commonly use and know is probably a sulfation. So the most common cause of battery failure within lead acid batteries is sulfation in itself. And this is a condition caused through primarily poor battery maintenance and associated with the voltage of the battery and the aging of it in the process. So here is just an image to show you really what a new battery looks like compared to a battery after 2000 cycles, where you can see the sulfate crystals building up on the plates, which cause the increased resistance of the battery. So when we look at testing the battery using the conductance tester, we can pick up the issue of the internal resistance, and hence why we then call and classify that as a defective battery. But that's certainly something we don't want batteries to fall foul of as best we can. And that's the only way we can cure that is through regular maintenance and testing. So some interesting facts for you there. A fully charged, a 12-volt battery is chemically empty at 11.7 volts. So really there's not much in it between a fully charged battery and a chemically dead battery. There's typically 1 volt. So fully charged voltage of a flooded battery is 12.72, and an AGM that's slightly higher at 12.85. So it just puts in perspective here that typically a lot of people think as long as the battery is above 12 volts, it's a good battery. It's not. Batteries suffer sulfation at around about 12.4 volts, and that really is where the devastation occurs with batteries. So you've just got to think of the current pandemic and situation we've been in. Lots of consumers and trucks, vehicles alike have been left dormant. If they're not maintained, we'll see a lot of discharged batteries which are suffering that risk of sulfation. With light sulfation, we can remove that through regular charging. If we allow the sulfate crystals to build up, nothing is going to shift it, and you'll end up having to replace the battery at quite significant cost. So, okay, we've got another poll question for you. So, George, if you can kindly open that for us, please. Great. So does your workshop equipment test and charge the latest battery technologies? So primarily we're looking at EFB batteries and charging with lithium. So have you got the capacity to enable you to do that? Just a quick yes or no answer will be good. Thank you. Great, George, and if we can shut the poll on that one. Okay, so we have 13% of yourselves have got that capability. However, 88% haven't. So that's going to be quite concerning, because if you look at EFB battery testing, as we said before, whilst a traditional test, you can test some of those EFBs, there's quite a few that you can't. So the risk that you have there is a missed opportunities of condemning a battery that may need replacing, but more importantly, you run the risk, if it's your own fleet of vehicles, that a defect is likely to occur and you'll incur non-start and roadside charges to go with that. So something to bear in mind when you look at how, the age of your battery testing equipment and what it's capable of doing. Not all battery testers are the same, and certainly the technology is moving on, as we're now accustomed to. And similarly with lithium battery, with lithium chargers, there are plenty on the market now. However, you have to bear in mind that if you're trying to charge a lithium battery with the traditional 12-volt flooded or AGM battery charger, it can be done, providing the battery hasn't fallen into the sort of battery management support mode where it's shut itself down. You need to reboot that with a lithium-based charger itself. Otherwise, it just won't recover. Okay. So moving on, we'll talk a little bit about our portal called Robis. So it's our online battery information system. We are very proud of this system. It's fairly unique, I think, in the industry and probably globally, actually. So it's an industry-first live battery management portal. We have over 4 million test results now uploaded to date from various customers, and this enables us to sort of track and manage their battery testing and charging practices to look at improvements or identifying opportunities for selling batteries if it's a retailer, if it's a fleet workshop, to look at how we minimize the risk of battery replacements, and more importantly, vehicle non-start. And these are all things that we can identify through the system and help workshops across the industry and globally, actually, on how to maintain and operate their systems as effectively as they can. I mean, one solution is great to buy the equipment to enable you to do the processes, but if your teams aren't using the equipment at regular intervals as part of a proactive process, it becomes meaningless. So the whole system is geared up to help you manage and drive forward those sort of best practices within your workshop environments. Okay, we have over 200 company users across 500 workshops using our system. The data is collected wirelessly using our EXP and CPX platforms. So as a user experience, you simply do the test, and as long as the test is connected to a wireless network, it will automatically upload the data. If the wireless location, excuse me, is temporarily suspended or out of range, as soon as you use the tester again within that range or power it up, will automatically upload the data to the Robis system so you can view the test result. Okay, so what I've done here really just give you a snapshot of some of our Robis users and customers that are using our system and getting the benefits and features of managing their fleets and workshop productivity much more efficiently. And we're very proud of having those partners with us. If we now look at some of the data, so of those 4 million test results, what I've done here is just giving you a snapshot of the test result that we've achieved from gathering that data. So quite a staggering result, I guess, as you'll see going forward now. So 52% of those 4 million battery tests were identified as good batteries. So that's roughly 1 in every 2 battery tests performed. The battery has been good. Typically 1% has been bad cell, which falls in line to what battery manufacturers would state, that less than 1% of batteries usually fell as a result of bad cell. 21% were replace decisions, and we have 26% that are good recharge. So you may or may not be surprised at those numbers. Certainly I was when I first looked at them, but it's no surprise to us in the longer term, because it's something that we specialize in working with companies to support. So if we see that again, so overall we've got 49% of all those batteries that are live in vehicle applications require some form of attention, whether it be just merely charging or actually replacing to prevent a non-start defect. 1% failed due to manufacturer defect, 27% required charging, sorry, 26%, typo there, to reduce the risk of premature failure, and 57% of the 24-volt battery sets that were tested were out of balance. And again, as we saw earlier, the out of balance is the early detection signs of a battery problem developing. So we need to remedy that through charging. Okay, so if you then break this data down further then into what we call industry segments, we've got then 5 listed there. So main dealer, commercial vehicle workshops, PSV, so our bus fleet operators, commercial vehicle workshops and fleets, main dealer for passenger cars, and then independent workshops. You can see here the Pareto percentages there. So the most effective processing we've got with good battery decisions is with our main dealer CV fleets. And that's predominantly because these guys are dealing generally with new batteries, new vehicles in the main, but more importantly, they're proactively testing and charging batteries at regular intervals. PSV used to be quite a low in the sort of hierarchy of testing and charging. However, they're much more effective now with the customers we work with, proactively testing and charging batteries at every sort of 6 to 8 week service interval. And that brings the performance of the batteries up very much significantly and reduces the risk of failure. So if we then look at where the heightened number of batteries that require charging, we can see that it falls within sort of main dealer, passenger and independent workshops. And that's probably not always been the case. I guess if we just look back at the past sort of year or so, we can see now a lot of consumer cars that have been stood around for many months without being driven, without being charged. So it's small wonder, I guess, that we see with independent car workshops, we see a very much increased requirement for vehicle batteries requiring charging. So that's a big opportunity for independent garages to proactively now look at charging customers' batteries as a proactive service, but more importantly, making some money out of it as well, because that's what we're in the business for, of course, to both increase customer service and generate revenue streams supporting your workshop businesses. And if we then look at the final one, requires replacements, we can see there with independent workshops, the category there, 27% of all the tests performed, the battery required a replacement. So roughly 1 in 3 vehicles. Okay, so if we now put that into perspective, into sort of physical numbers and opportunities, I guess, we can look at what we call the return on investment calculations. So if we look at the average diagnosis opportunity, so from the data we've seen there, roughly 26% of all vehicles require charging, and that's roughly 1 in 3 vehicles that enter the workshop, and 21% of batteries require replacement. So that's 1 in 5 vehicles typically. So you may or may not be surprised with these numbers, but these are factually produced. We haven't pulled these numbers out of the air. It's taken across all our sort of workshop segments. So you can be rest assured this is a true perception of what's going out in the marketplace. So if we look at a calculation then, so the calculation we'll run through now is just based on throughput of 5 vehicles being serviced per day over 5 days. So a very small number there. So we've got 8 charging opportunities. So again, we look towards the industry of actually saying, how often do we look at charging batteries? Do we ever do that as a positive service for customers? And more importantly, can there be a revenue stream generated from charging a customer's battery? And the answer is absolutely yes. We've got proven case studies out there with customers that are charging anything from £5 or £10 to charge a battery up. So if we just consider a £5 nominal fee to charge a battery, over this category, we can see that there are 8 opportunities in the week, equating to £40 of revenue, just simply for hooking up the charger to the battery whilst we carry out a service or inspection. If we then look at the replacement opportunities, there were 5 in this study. Average replacement cost being, say, £150. So that's an additional £750 worth of revenue. So if we then sum those numbers up, we can see that revenue generated weekly, we're looking at roughly £790. Monthly, if we look at just 4 weeks in a month, that's £3,160. And annually, a whopping £37,920. So it puts into perspective really that, if you start looking at proactively testing batteries and charging them, there is a great revenue stream, but more importantly, there's an opportunity to provide service and satisfaction to your customers at the same time. So in sum, if you're an independent workshop, the benefits for yourselves are increased customer services and revenue streams. If you're a fleet operator or owner, you're going to see the reduced risk of breakdowns. You'll see a reduction in battery spend and vehicle operating costs. So in a nutshell, this is a no-brainer. Proactively looking at battery management and maintenance of your batteries, whether it's for customers or your own vehicle fleets, is a no-brainer for sure. Okay, so what we're going to go on to another poll now. So our last poll of the century, as they say. So George, if you can kindly bring up the next question for us. Okay, so how often do you have your battery testing equipment, whether it's testers or chargers, serviced or calibrated? So we've got 4 options there: annually, as per the equipment guarantees, rarely, or never, or I don't know. Great, so if we can just close that poll down then, please, Georgia. Great, okay, so what we've got annually, we've got 18% of you say that you have your equipment tested and calibrated, 6% have it done as and when the guarantees recommend, 35% say rarely, and 41% don't know. So again, some interesting results there again. You know, there's always a proactive approach that if you can close that one down, that's great. Thanks, Georgia. It always makes sense, I guess, really. We come across quite a number of customers that either have a piece of equipment that's stood underneath the cabinet in the workshop that's not used, just collecting dust. Some users will carry on using the equipment, albeit the cables may be worn, causing misdiagnosis, missed opportunities, or, you know, unfortunately situations where vehicles will leave the workshop with a faulty battery that's undetected. So it's always a good practice to at least look at the last time your equipment was inspected, just check for worn cables, conditions, etc. Again, using our Robis system with some of the platforms, we pick up things and we can detect if there are defects within the tester, so we can alert you maybe even before you're aware of that problem developing. But it's always a good practice to keep it in good health and good check at periodic intervals. Okay. So if we look at next steps, I guess, really, you know, it's about keeping your vehicles on the move for longer, whether it be your customers, your own vehicle fleet. And this is something we pride ourselves in, and we can help develop situations and programs to enhance those capabilities within your own businesses. So I guess for myself, I would hope you feel you have a better understanding now of the emerging battery diagnostic technologies that are about and what are available to yourselves. You hopefully have the ability now to identify, action and maintain batteries that you support within your workshops and your teams. And you have the ability to change and enhance the way you service your customers and vehicle batteries in maybe a slightly different way than you've been accustomed to or maybe considered. Okay, so how can we at Rotronics support you further going forward? We can help you prepare for the future requirements for sure with our equipment and our knowledge base. We can work with you to understand and implement a proactive plan based on our experience and knowledge. And together we can develop bespoke plans for your fleet or workshop needs so that you get the most out of both your technicians' downtime and productivity, and more importantly, for the opportunities of increasing either revenue streams or satisfaction for your customers. Okay. And really sorry, on that final note then, really, I guess we'll now look at going through a Q&A session. If you have any questions, etc., for us, I'm more than happy to sort of pick up where we can with any questions that you may have for us. And I'll just hand over to Georgia now. So thank you.
That is brilliant. Thanks so much, Ken. Amazing. Okay, so let's start the Q&A. So I see that we have one question from Lindsay. Does Robis work with any tester?
A good question, actually. No, it only works with our EXP platform. So it's an EXP 1000 testing platform, which is a Rotronix product, and our CPX 900 Robis platform. Again, it's a Rotronix product platform. The reason for that is we have these wirelessly enabled to fit within the Robis portal, and the configuration of the tester that's recorded is stored in a certain format. So it only works with those two platforms, unfortunately. But a good question. Thank you.
Perfect. And what would you say, which battery is the best battery to use? I mean, there's so many different types. There must be one that stands out.
Yeah, it's a good question, and one we get asked quite often, I guess. And I always revert back to an easier question to put back, I guess. Really, it starts off with actually how you look after the battery in the first place. If we quite often come across workshops that are unhappy with the batteries they're using, or they're not lasting in their fleets, they just randomly change to either a more expensive battery or a different technology. And different technologies can give enhanced features. So moving from a flooded battery to an AGM battery can give you better performance characteristics. However, the caveat would be if we do nothing to maintain that battery any differently, it's not going to give us any great length of performance. So I'd always start off with saying, look, let's understand how you're looking after your batteries first. Are you testing them? More importantly, are you charging them at regular intervals? And then let's measure, and we can do that through the Robis system, on how efficient your batteries are. And actually, is it you causing the problem to your battery performance, or is it actually a quality issue with the battery? So we'd always start with that. So hopefully that answers that question.
Brilliant, thank you. We have one from Poppy. How often should I test and charge batteries?
Again, from my perspective, it would be as often as you possibly can. You're not going to damage batteries by testing them and certainly charging them. So, for fleet workshops, we recommend at every inspection interval, whether it's a 6, 8 week or 12 week interval process. With individual customers, you're not going to get cars coming in every month or 2 months for inspection or service. But certainly any car that comes into your workshop or any commercial vehicle, in an ideal situation, we should test and charge every time. Because by doing that, we'll just keep topping up the battery where it needs it. And as you saw from some of the data we presented earlier, there are a lot of batteries out there in quite heavily discharged state. So if we can reduce that risk of premature failure through regular charging and testing means, why not offer your customers, to come in at quarterly intervals for a free battery check? It gives you a great opportunity to meet your customer and offer them maybe a free service. But more importantly, you can pick up any issues they've got with their vehicle at the same time and be more proactive about it rather than waiting for customers to break down at roadside and then you miss out on that opportunity. Okay.
Perfect. Okay, so we have another one from Lindsay. So how frequently should I be testing? Oh, no, that's the one.
Yep.
Sorry, that's what Poppy wrote. Paul says, can using older type chargers damage EF and AGM batteries?
I guess it depends what you mean by older chargers, but I would say if it's a constant current charger, yes, absolutely, because those by their very nature are not very clever, I guess, in terms of putting current into the battery. It will just force current into a battery. The modern day sort of smart chargers, if they're designed for flooded batteries, they'll work fine with the FBs. AGM, in itself, I mean, there are various chargers out there that will have specific charge algorithms for different technologies. I always prefer them to be the best because the voltage is slightly differing for a regular battery or an AGM in terms of charging. But certainly, as long as it's a smart charger, you're pretty much fine with that. It's really when you come into lithium that you have to be a bit more careful with it. But certainly, AGM, EFBs, they are all still from the flooded battery range, if you like, so you can't go far wrong. Okay.
Perfect. Okay, and does Robis provide any further training to workshops directly or colleges studying motor vehicle?
Absolutely. I mean, we're always open to sort of work with customers. We're obviously in the business to make money as well, but the best approach for us is to work with companies and industries to actually help spread the message of battery maintenance. I guess it's one thing that I guess never ceases to amaze me. I guess with battery maintenance and awareness is something that's not really on the syllabus in any detail, I guess, really, but we've made a business out of it. Because there's a big need, I guess, to educate people, and it's not rocket science in my view, I guess, but there's a lot of, I guess, misunderstanding about what batteries are all about. And, the old sort of analogy that it's a fit and forget and it's either good or bad actually doesn't exist, So, yeah, absolutely get in touch with us and we can certainly help work with you to either put some training packages in place. We're very impartial in what we do. We don't care which batteries companies use or which technologies. We're here to just give very impartial and professional advice on how to get the most out of both your technicians and your workshop practices. So yeah, get in touch with us and we're happy to help you for sure.
Perfect. I also want to mention that Ken's details will be included in that follow-up email with the recording. So you can get in touch once you have that email.
Okay.
Perfect. Okay. What is the best way to test 24-volt sets or these sets?
Yep. Okay, with 24-volt battery sets, I mean, you can use any tester, a 12-volt tester to test batteries. I guess we have a specific tester designed for 24-volt battery sets in our EXP1000 FHD platform, because with a 24-volt battery set, you want to know both the voltage of each battery and the capacity of each one. So, and you can do that in a simplistic way, I guess, by looking at, is the voltage the same on both batteries? is the CCA similar? But that's not a very scientific way of looking at it. With our testing platform, you test both batteries individually without connecting the brace, and the tester will tell you whether you've got a good pair and the battery set are in balance. Because you can have two batteries in a 24-volt set that are good, but if they're out of balance with each other, that's not a good thing. So the charging system will continue to increase that imbalance and further risk, the batteries degrading earlier than they should be. And we see this primarily in things like boat applications, so marine applications and commercial vehicle sets, or even on gen sets, where they've got 24-volt sets of batteries or more. So yeah, getting that balance right is a key sort of remedy, I guess, to prolonging battery life. So yeah, certainly that's the most effective way and simple way of testing batteries. You can take the hard work out of guesswork really by doing that. Okay.
Perfect. Okay, just two more left. What are the warranties on the new tech batteries? Is it more than lead acid?
Well, yeah, I mean, I guess warranties are a funny thing. I always look at, if I was to ever sell batteries, and I never probably would, I think warranties are almost a bit of a misdemeanor to a degree, I guess, because manufacturers offer different warranties for different applications. Some give no quibble warranties, some give 12 months, some give 2 years, some will give you bugger all. Some will give it based on manufacturer defect alone, so bad sell. Some will give you a 12-month guarantee with limited variations. Some will buy out the warranty processes, I guess. So for me, I'd always look at, for batteries, I guess warranties is always the thing we should look at last, rather than saying, how do I mitigate that battery becoming a warranty in the first place and a casualty? So hence why, if we look at proactive maintenance, we can then extend that battery beyond its warranty time anyway. So, for me, you can get range of 12 months, 24 months, 3 years, 4 years warranty. But, whether your battery provider will give you that warranty claim back if it's abused or misused. Again, the great thing with the Robis system, you can track the performance of that battery over time, because all too often we hear that batteries are failed under warranty. We know that a legitimate warranty percentage is less than 1%. So if you've got 100 batteries that fail, only 1% will actually fail genuinely of manufacturer defect. 99% will fail due to premature failure, through to misuse, abuse, incorrect fitment, etc., or lack of maintenance. So I always try to rewind back and say, let's forget about the warranty, let's look at warranty mitigation in the first place. And we do the same with vehicle manufacturers. The testing equipment has always been there to identify, who do I point the finger at and shoot the gun, if you like, for warranty claims. I always like to look at a stage back at that and say, how do we mitigate that in the first place? So hopefully that answers that question somehow.
Perfect. We've got a few more that just come in as well. So how much information will the testers hold when out of Wi-Fi range?
Indefinitely. Yeah, good valid point there, really. I mean, it's got an internal memory, so okay, you can have several hundred tests, I guess, really. So if you're out in a compound, you're doing lots of testing, or your Wi-Fi goes down, depending on which Wi-Fi provider you've got, hopefully it's a good one. But yeah, it will store numerous tests in there, so it's not just limited to 5 or 10. So hopefully by the time you've done testing, if you're roadside use and then come back into a hub, it will upload. The only downside to that is sometimes if you've got 10, 20, 30 tests, it might take a few moments longer to upload the test. So we'd recommend, if you've done a lot of tests, so maybe 20, 30 tests, power up the tester when you come in the range and just wait for a couple of minutes, but normally it's an instant transmission that goes over the air. So hopefully that answers that question.
Perfect. And what should I do if my battery tester needs a repair?
Okay, well, if it's a Rotronix based one, you can certainly get in touch with ourselves on our website and fill out an online repair form, and then we would get in, you can send that in to us, print off a copy of the document. We get a notification that your test is coming in for repair, or whether it's a charger, and we contact you then as soon as it arrives, and we then give you a quote within 24 hours of the nature of the repair and what it would cost to get it fixed. A lot of the lower end testers are designed as throwaway products, so I guess it depends on which product it is. But certainly, the good thing with Rotronix platforms, they're all repairable and serviceable, and some of them are upgradable to new technologies as well. So if you've got a quality tester, it's worthwhile getting it across to us. Just don't throw it out thinking it doesn't work. There's nothing wrong with us just giving you a quote to let you know how much it costs to bring it back up to scratch. Okay.
Perfect. And would you advise on a 24V circuit replace batteries in pairs or whichever failed?
Again, I mean, you know, there's different views on this one. Some manufacturers have a view that if the battery, if a new battery set fails within 12 months and only one battery's gone down, you can just stick another new battery alongside it. I have a different view that, you know, take the guesswork out of it. Use the EXP battery test to generate a pair. It'll tell you whether the battery set's in balance, because if quite often you will get one battery failing for the other, and that's largely down to this imbalance issue. If you look after both batteries individually, they'll usually decline over time at the same rates. It's because we've got this imbalance through the charging system that we get this degradation of one battery over the other. But yeah, it's a valid point, and I would say, you know, ideally, yes, you know, if why throw away one battery that's very serviceable and good when you only got one that's failed? Equally, you could pair up a second-hand battery with another second-hand battery, and providing they're compatible in terms of performance, not just looking at the label, but do a battery test on them. Again, ideally, the EXP FHD will take that guesswork out of the process, and it will tell you whether they're a good pair. And you'll probably get another 12 months life out of the batteries. Eventually, they're going to fail. They're not going to last as long as a brand new battery. But I never believe in throwing stuff away if it's got another serviceable lifespan with it. And we have a lot of customers out there that we've proven that, you know, don't throw both batteries away when only one's faulty. You can pair them up with other batteries and utilize that and get extra revenue, you know, or get extra benefit from it, and cost savings. So yeah, it's a good process to take for sure.
Perfect. And our last question, is there a self-calibration on the expected 1,000 range? Yeah, that we can
I mean, a self-test, I guess, really is to just look at testing. You know, if you're testing the same battery several times, you should get a reading very close to the previous reading. So if you've got a battery you're testing at, say, 1,000 amps, and you're getting 995 amps on test 1 and 990 amps on test 2, and on test 3 you're getting 992, then it's fair to say that those batteries are relatively okay. Sorry, the calibration is okay. If you've got quite a sporadic range variation of 100 amps, 200 amps, then it either could be down to a fault with the lead set, or that a calibration is recommended. And we normally would say that, you know, on these platforms, getting a verification calibration done annually or biannually is certainly recommended, because if nothing else, the cable sets do wear out. You know, it's a perishable item on the tester itself. So the more you use it, the more the risk of that resistance building up in the cable. So again, we can offer a calibration service or verification. And if you're using the Robis system, again, we can pinpoint those trouble hotspots if, you know, a temperature sensor has gone down as well, because some people may not know this, but on the EXP, if you've got a temperature sensor that suddenly gets spiked, it can increase your replace decisions by 30%. So again, it's not just looking for the obvious signs that it's out of range, but temperature ratings can also have a big impact on the tester functionality as well. So it's a good way to have a health check anyway, for sure. Good.
Brilliant.
Great. Any more? No, I think we're done. We're exhausted.
No, I think we got through 11 questions, so that is really good going. Thank you to everyone who submitted your questions to Ken. Thank you for your time. You are very welcome. Thank you so much for submitting your questions in that Q&A session. Lots of information there, and hopefully a lot of good answers to your questions. I think that's about it for today. So thank you so much for joining us. Please keep a look out for future webinars on the IMI website. And lastly, I'd just like to say a huge thank you to Ken for delivering such a fantastic, very detailed and informative presentation.
You're very welcome, Georgia, and thank you very much indeed. It's been a real pleasure. Thank you.
Thank you very much. We'll see you all again soon. Thank you. Bye.
Bye.